All right, let's start by looking at number 12. Use the order of operations to simplify the following expression. 1 minus, in parentheses, 1/4 plus 1/6. So for this, we're going to need to sing our song. When we begin together. Parentheses first, now please be clever. Exponents come right next in line. You can multiply or divide at the same time. Now subtraction and addition. Work it out with computation. It's the order of operations. It's the order of operations. A plus order of operations. So our song tells us that we start with parentheses, and we do have parentheses here. We have 1/4 plus 1/6. So that's where we're going to start. I'm just going to rewrite that 1/4 plus 1/6 vertically because that's going to help me solve it. I'm going to switch over to my fraction song. I'm going to say number 2, denominator must be the same. Find a common multiple and then rename. So I'm going to find my LCD of 4 and 6. 4, 8, 12, 6, 12. My LCD is 12. Number 3, equivalent. It's a denom swap. What you do to the bottom, you must do to the top. So we say 6 times 2 equals 12. So we come up here, 1 times 2 equals 2. 4 times 3 equals 12. Come up here, 1 times 3 equals 3. Number 4, solve. Our denoms are the same. Let's add or subtract to finish this game. So we have 3 plus 2 is 5/12. So 1/4 plus 1/6 equals 5/12. So I'm going to put my caret here. Get rid of this work because I'm running out of room. Put in 5/12. Bring everything else down. 1 minus, and I don't need those parentheses because I've already solved it out. So no more parentheses. Moving on to exponents, but we don't have any exponents. Moving on to multiplication and division, none of that, but we do have subtraction. So we're going to do 1 minus 5/12. So the first thing I'm going to do is I'm going to set this problem up vertically. 1 minus 5/12. And I'm going to just erase that real quick so I have some room. I'm going to put a 0 here because I don't have any whole numbers. And I'm also going to put 0/12 here because I don't have any fractions. All right, so I've already got that common denominator, so I don't need to do steps 2 or 3. So we say step 4, solve. Our denoms are the same. Let's add or subtract to finish this game. We say 5/12 minus, or 0/12 minus 5/12. Stop, regroup. We can't do that, so we're going to head on over here to the 1. We're going to turn that into a 0. We're going to take that 1 whole, and we're going to add it as a fraction of 12/12. Now I'm going to rewrite my problem as 12/12 minus 5/12. Now we can solve 12 minus 5 equals 7, and my denominator stays the same. We don't need to simplify it, and so we have our final answer of 7/12. Number 13, James ordered 4 pizzas. If each slice is 1/8 of a pizza, how many total slices are there? James orders 4 pizzas. Each slice is 1/8. We're looking for how many total slices. So here's my 4 pizzas. Okay, we're going to split our pizzas up into 8s. So that's 4 and 8s. That's 4 and 8s. That's 4 and 8s. That's 4 and 8s. And we're asking ourselves, how many slices are there? Where there's 8 slices here, there's 8 slices here, 8 slices here, and 8 slices here. So we could add that up, or look at that, repeated addition means multiplication. So we could say 8 times 1, 2, 3, 4. 8 times 4 equals 32. So there are 32 slices of pizza. Now we solved the problem using models and just using common sense. But if you want to know how to solve it mathematically, what you're actually doing is you're taking these 4 pizzas and you're dividing them into 1/8 slices. You're taking 4 whole pizzas and you're dividing it into 1/8 slices. So we could also solve it using standard algorithm, where we say, keep the first fraction, keep it the same. Ain't no reason to alter its name. Change the op symbol, it says to divide. Change it around, multiply this time. Flip the last fraction, flip it around. Reciprocal works better, or so I have found. Keep, change, flip. All right, keep, change, flip. Okay, keep, change, flip. You know, keep, change, flip. Let's go. Then we multiply like normal. 4 times 8 is 32. Put it over 1. Any number over 1 is just that whole number of 32. So you see we did it the same way, whether we did it through models or we did it through standard algorithm. The answer is that there are 32 slices of pizza. Number 14. 3/4 of the class are boys. 2/3 of the boys are wearing tennis shoes. What fraction of the class are boys wearing tennis shoes? So let's think about what's going on in this problem. We have a class. In our classroom, we have boys and we have girls. We're just talking about the boys. We know that 2/3 of the boys are wearing tennis shoes. So some of them tennis shoes, some of them maybe they have on some sandals or some boots, or maybe they're just barefoot for today. Who knows? But we want to know what fraction of the class are boys wearing tennis shoes. So we need to find a piece of the class, boys, and then another piece, those boys wearing tennis shoes. We're finding a piece of a piece. A piece of a piece. We have that word of here, and we know of means multiplication. When I look here, I see 2/3 of the boys. Well, how many boys are there? Well, 3/4 of the class are boys. So all of a sudden, we start to see this 2/3 of 3/4. We want to find 2/3 of the 3/4 boys. It's not just 2/3 because we don't have a class of all boys. Only 3/4 of our class is boys. So this is actually a multiplication problem. 2/3 of 3/4 or 2/3 times 3/4. And so when we multiply, we just multiply the numerators. 2 times 3 equals 6. And we multiply the denominators. 3 times 4 equals 12. But wait! 6/12, we know that that can be simplified all the way down to 1/2 because 6 is half of 12. So half of the class are boys wearing tennis shoes. That's a lot of boys wearing tennis shoes.